Hey everybody, welcome back to HPC Tech Shorts, where every week we're going to take you to the HPC engineering water cooler to talk to the engineers, the architects, and the other nerds that are making the cloud an awesome place to do your HPC. This week, I'm very happy to say, we're joined by Angel Pizarro in Philadelphia. Hey, Angel.
Howdy. For
the second time, because we forgot to hit the recording button the first time.
They don't need to know that.
I got to fess up.
Right.
So for everybody else's sake, for the viewers at home sake, we're going to talk about HPC storage today, because we've got like a whole bag full of HPC storage options. Angel, when you were a customer before you became an Amazonian, we had two storage options, right? EBS and S3. Now we've got it feels like we've got 11 storage options, and there's 32 sub options inside each one, because there's infrequent access, single zone, et cetera. We're going to try and cover as much as that as we can today. But the thing that makes you special in our team is that you were a customer before you were an Amazonian, and you were a hardcore, scale HPC customer, and you were using this stuff for real very early in AWS's life inside the research sector. So give us a bit of background there.
Yeah, so my background is I was a bioinformatics researcher / systems engineer at University of Pennsylvania. My focus was on supporting large-scale core facilities, so the sequencing facility or the proteomics facility, with their infrastructure needs, but also work on our labs research projects. So we would do large scale experiments ourselves and had our own need for computation. And around from around 2012, 2011, 2012, when we were running an HPC infrastructure that had, back in the day, a petabyte of storage was quite a lot. We didn't quite have a petabyte of storage and a couple hundred nodes to service the university's genomics customers. Illumina's sequencing chemistry kits did update themselves to produce more data, almost double the amount of data from the same instrumentation. So overnight, we suddenly had the need to analyze way more data, pretty much for the same cost of reagents, which really puts a wrench into your hardware procurement plans. Maybe we should switch to looking at what we have today.
Yeah, let's do that. Let's do that. So we've got our basic sort of anatomy here is, block storage, shared file storage, object storage, and then stuff inside EC2 instances, which people shouldn't overlook, right? That latter category. Some of our instances, particularly the ones these are the ones typically with a D in their name. Yep. So a P4D.
M5D, yep.
Right,
P4D.
M5D. Often you'll see a lot of DNs, because that means they've got high performance networking as well as high performance storage. But those local scratch disks can be, really super fast.
Absolutely, and if your needs fit within those scratch storage, it's fantastic. You should definitely leverage it. So, like I mentioned, our object storage S3. This is the first thing that we leveraged in terms of data staging. We still recommend really treating S3 as your source of truth for longer term storage, and staging data as you need to from that object storage into other services, whether that's an instance EBS volume, or whether that's a shared storage or parallel NFS services, which we'll get into. S3 is really a game changer in terms of paying for storage only for what you use. And it was a really attractive product back then. It's still an attractive product today.
And some of the things that people overlook about S3 that are really attractive, right? S3, it lives inside a region like all of your other cloud resources do, but it's visible in every single AZ inside the regions. Mm-hmm. So, so it's it's a fully synchronized object file store amongst the AZs. That actually means that when regardless of where your compute resources are spread amongst the AZs, you're not incurring any cross AZ traffic charges. You're just pulling straight from local. And the other thing about about S3 in particular is, I mean, the durability, the 11 nines of durability is insane. And if you're storing petabytes and tens of petabytes of data, like a lot of scientists are doing, those 11 nines actually matter to you.
Absolutely. I think that's one of the sort of fallacies that folks go and try to compare object storage prices to a disk on a shelf. If you ever really don't want to have a heart attack, don't look up bit rot rates. Essentially magnetic, either solar flares or just failure from the platters in that disk that you have on a shelf. There's going to be bit rot, and for things like MP4, like movie, that might not matter, but for scientific data, which is usually almost every bit counts, or you don't know which bits count, and it's highly compressed and highly information rich data. Bit rot makes quite a bit of difference. But unless, the other thing is, unless you're constantly checksumming all the blocks, and there are some file systems that do that and move data automatically, the majority of them don't. No. Right? They only repair blocks on read. So you must have some process that's constantly reading and moving your data. So again, these are all operational things. These are all go into the cost structure of storage. And the amazing thing about S3 and object storage is that all that's hidden from you. It is absolutely reasonable price.
Yep. All right. So let's talk about that.
Sure.
S3 use case.
Right. So let's zoom in a little bit on, I mentioned parallel cluster, the spiritual successor of Star Cluster and other products. Again, it bootstraps a traditional scheduler. So the way that we see folks using it is that they'll be in their lab. They'll stage data into an S3 bucket. These objects are there for their use. They're not standing up a service, so they're not, in order to move the data to S3, all of this stuff up here is actually not being used yet. So it's not incurring any costs. And then two, they'll stand up their parallel cluster and start sending jobs to it. The auto-scaling group for the instances will start, once there are jobs in the queue, start waking up and then pulling data. So one of the caveats of this model is that the job that you send, whatever that script is, send to the compute node has to know that it has to pull data from the bucket before it can start work. And then do that work. And at the end of it, stage data back into that S3 bucket before it goes away. Right. And this is a fairly scalable, as you scale the number of instances, S3 may have some upper bound on the amount of data that it can transfer per instance, but horizontally, it's just a fantastic way to distribute data across instances.
Yeah. Well, Stephen Sachs talked about that last week when he was showing us how he uses CloudWatch metrics to actually cause a cluster to push data off an OpenFOAM workload, pull it out of an OpenFOAM workload, and massively transmit it to S3. He said at the time that the parallel scaling of S3, that performance it's a monster.
Yeah, it is a monster. It's great. And we discussed different regions. We have this other service which is managed containers on the cloud with batch scaling for the execution nodes called AWS Batch. This is an alternative to traditional HPC schedulers like Slurm or PBS or LSF. The use case here is traditionally still, upload data to a bucket, stage it there, define a job task and submit jobs into a job queue. That job queue goes through and the batch service itself is managed. So it'll start scaling nodes where they're available across an entire region. And then these instances can pull and push data. Again, the jobs that are in here, need to be aware that they need to pull and push data from S3. But like we said, for most work, this is a non-issue.
For a container to pull an object out of S3 with an AWS CLI command is trivial.
Mm-hmm.
So it's not hard to orchestrate this stuff at all.
Correct. And the benefit here is that you're not even running the scheduler node and incurring the cost for a long-lived instance.
Right.
AWS Batch takes care of all of this for you.
Yeah, and this is one of those cases where batch is multi-zone, multi-AZ in a region, and it's using the aspect of S3 as multi-AZ as well. And so you just simply don't need to care about where the resources are going to spring up, right? Yeah. Anyway, I think the other thing is some of the biggest batch users that we've got, in the cloud, people like Mobileye and others they're scaling up hundreds of thousands of cores a day doing just this kind of scenario.
Let's go back to sort of parallel cluster, because we see a lot of uses about shared storage from that group, right? So we talked about block storage, making the note that instances themselves can stand up with either instance storage that's available to them, or you can have launch templates or other things that attach block storage and additional storage onto those instances so that you have that scratch space. You also have the option, at least within the parallel cluster config, to define a volume, an EBS volume, that is shared by NFS, traditional NFS. This isn't parallel NFS because you have only a single node providing the network access. So this is traditional NFS share to the nodes. They attach to that, and they can shift data back and forth. And you still have the option of pulling data to and from the bucket, right? So this is a good way to mix up staging data at runtime from a bucket versus things that are longer lived and you're going to need access to. So things like reference data for an algorithm or applications or other things that might have, you're going to use it all the time, and you don't really want to spend any time staging it. You just want it to be available to the instances as they boot up.
Right, or the amount of time that it takes you to read the data in versus the amount of time that you need to work on the data, process the data, and write it out are dramatically different, right? So, image analysis of satellite photography or, looking for artifacts and so forth.
One thing that I've seen a lot too is that folks will start one job to stage data into a volume, and then the rest of the jobs are dependent on that job to finish, to then scale out to read and write data to that volume so they spend only one of their instance hours to do the staging for all the rest of them that come. So you amortize the cost of data staging across a set of workloads. So that's a pretty common use case as well.
Yep.
But if you don't want to spend your time orchestrating that, we have this nice real parallel NFS service called Amazon FSx for Lustre. I'm talking Linux here. We also have it for FSx available for Windows, but for Lustre and Linux file systems, you can stand up a quote unquote real parallel NFS system attached to.
Well, we should say it's not really NFS. It's Lustre. This is And this is real Lustre, scales out all of the bells and whistles, but it's Lustre that's kind of weird.
Yeah. One of the nice things that you get out of the box is being able to automatically set this file system as a cache to an S3 bucket. So your nodes are actually talking to the file system, and as they request data from something that lives in S3, that FSx file system will stage it onto the POSIX file system. So your first read will be at the rate that you can get from a bucket, but every subsequent read will be at the parallel NFS, quite fast sub-millisecond reads into the instances themselves, and that's a pattern we see a lot.
And that really means you've got the ability to just take data out of S3, you could have a petabyte of data in S3. You could spin up an FSx file system in front of it and use it like a giant cache to just elevate the performance of that data, right?
Correct. Yeah. So you can use it as a cache to elevate performance of data in S3, have your scratch storage, either be on the instance or the file system. Again, your workload best. But have that extremely fast, parallel NFS performance to your instances to do your workloads as quickly as possible. And today, at the end of it, if you do want that data to go back into S3, there is a command you can give to FSX to push that data back into the bucket once your workload is done.
Yeah, and those buckets that you're picking to mirror in your Lustre file system, they could be public dataset buckets out of our public dataset programs. Like, so other people shared S3 buckets where they put reference data. And what's interesting about that, there's in the spirit of your workload best, FSX for Lustre, when it does mirror an S3 object, an S3 bucket, it's a lazy loader. So what it actually does is it sets up the skeleton of the file system, all of the file system inodes, as essentially as stubs referencing the objects in S3, and only loads them when you go to open the file and pull it through. If you know your workload better and you know that you need a bunch of the actual data payload of the files cached first, you can just run a command to actually pre-cache a portion of the, whatever portion of the S3 bucket that you think you need pre-cached. In other words, sort of preloaded before you start working. But this is an incredibly powerful. This is an incredibly powerful model.
Mm-hmm. Absolutely. And at least for, in AWS Batch, I'm not covering it here. You can have a launch template that is tied to for compute environments that are EC2 based. There's different compute environments for Batch. I'm not going to get into it, but for EC2 based compute environments, you can have a launch template that automatically mounts that FSX file system on your behalf. So you can essentially, trade Batch for a parallel cluster in this scenario.
Right.
Speaking of Batch,
hang on, just before you shift, I want to point out to everybody, I just want to put this up. This is where you find the information about FSX Lustre's performance. And the reason why it's interesting is when you specify an FSX for Lustre, you specify the size of the file system that you want, and you get a built-in certain amount of performance that comes with that. So you've got these sort of predefined ratios in the different tiers of FSX Lustre, whether it's hard drive backed, like traditional magnetic storage backed or SSD backed, and you can essentially make some choices in FSX for Lustre's configuration so that you can choose the performance you want. You could get hundreds of gigabytes per second of cross-sectional bandwidth if you needed it. Yep. So anyway, let me get out of the way. Keep going.
Yeah, yet another parallel file system that we have, Amazon Elastic File System. This is different from FSX in that, it's not standing up what instances on your behalf. It is a fully managed service. It's regional service. So it can be a regional service. So it stands up that NFS4 protocol that is across the regions at a really simple price model. Let me get rid of that. Really simple price model. And it's available across zones. So the model that we talked about where you had data staging into an S3 bucket and then all nodes reading from that S3 bucket across zones, no matter where you are with Batch. The same can be done with EFS for Batch at the job level. So the interesting thing is that you can define jobs that say mount this specific point for my job, my type of job, the job description, to this subdirectory of EFS. So you're not giving full access into all of EFS. You're controlling where at the, how you define this job, where it gets its data from, and other things like who, what user group, what users can actually access this, and a whole bunch of other controls around file system permissions available to the job at the job level. So this is really cool. We have a blog post on this as well. We'll put it in the show notes. I neglected to put it on here, but we'll put it in the show notes.
Okay, but it's findable here in our HPC blog channel. So yeah,
that's correct. If you just search for AWS Batch and EFS, then you'll get right to it.
And EFS is also good for like home directories too. Like a lot of folks just use EFS because it's persistent. It's like S3. It just stays there until you go, getting rid of it. It's highly persistent and distributed across the region. A lot of folks just find it convenient for home directories.
Correct. Yeah. So moving on to AZ in parallel cluster. I know this is going to get a little bit more complex. Parallel cluster is today, a single AZ aware. So it stands up all the resources within an availability zone. Sometimes you need to for whatever reason, scale your job across availability zones. In that case, you're standing up another parallel cluster, cluster. So this one would be cluster AZ1, cluster AZ2, and you'd need to submit jobs separately to those head nodes. There are ways using Slurm's native functionality to make this a sub.
Yeah, like a stretch cluster.
Yeah, a surge cluster, a subcluster so you only have one submit host. Again, I'm not going to get into it because that's a lot of information. But, again, using this file system, you can both read from the bucket. When you do the data stage and back out, though, you should be aware of, not clobbering from these two things, right?
But the resynchronization does actually allow you to like provide a regular expression or some other subset for being able to specify what you want synchronized back into the S3 bucket, right?
Correct. Yeah.
So you're not stuck with just the whole thing. So
that's
an interesting example of just scaling clusters.
Yep.
My cluster isn't big enough. I built another one over here, just a little bit further west. There you go.
Yeah. And we can get even more. You can also attach Amazon EFS. This is outside of parallel cluster. You would need to define this as a separate NFS mount into your parallel cluster config. So it's a little extra step, but it serves as its native cross-region parallel cluster. So that's an option too. We see most folks when they're using parallel cluster rely on FSX for Lustre. Just know that EFS is also an option.
Yeah, that's true. Hey, can you just zoom back up to the top of the very top of the page again, back to our original little block of all of the different storage types, because we've covered them all, which is impressive in a little over 20 minutes. No, what I want to say here is, so block storage is your traditional EBS attached to an EC2 instance. Don't forget, of course, as the yellow sticky there says, don't forget the stuff that's already in an EC2 instance in some cases that is highly performant local storage. We've got these really cool shared file systems that are regular POSIX file systems provided as a service and shared across, sometimes in individual AZ, sometimes across a whole region. And then, of course, there's S3, which is just everywhere, and it is kind of, I'm sure it's the world's largest data store. It's just enormous. Keep your eye, like when you're actually picking one of these things for your workload, given a lot of HPC customers run things like MPI workloads, which, of course, you don't want to run an MPI workload across two AZs. So, there's a tradition with a lot of HPC workloads where they live inside a single AZ. They just pick an AZ and just set up shop there. Keep an eye on the options with these services for picking the single AZ version of it, right? There is a single AZ version of EFS, and it's a lower cost service, but it still provides all the same functionality. It's just that it's only in one AZ, right?
Yeah, that's called EFS one zone.
Yep.
The sticker label is on the box.
There you go. Just what it says on the tin.
That's what it said on the tin.
Yeah, I mean, it's worth looking at all of these things. FSX for Lustre has a bunch of different tiers for the storage. Keep an eye on all of those. I guess the last thing to say is, if folks out there have got some ideas about what they'd like to see us talk about in the future, and in particular, if there's some storage areas that we should be diving deeper into, and we're going to have a few of those coming soon, please DM us on Twitter. DMs are open, or just come and find Angel or I. You can see our Twitter handles here. Come and find us online. Beat us up and tell us, there's a particular topic that you want us to cover in one of these shows, and we'll look at doing it. But Angel, in the meantime, thanks for coming in today and talking to us about all of this stuff and sharing your experience. This has been really cool.
My pleasure.